All right, can you see and hear me okay?
Yes, looks good. Thanks.
Okay. Smaller. Okay. Yeah, so our proposal was, I think, one of the few proposals proposing to develop something kind of new, although it's also kind of old. So we wanted to develop an adaptable and an extensible library for annotation of video for machine learning purposes. And so this is motivated by a couple of reasons. One is that computer vision right now, to a large extent, is still focused on images. So this is some numbers that I pulled from Papers with Code this morning, that there's about three times more image data sets than there are video data sets out there. You can also look at the number of papers that are run on these different, are devoted to these different types of data. So these are some of the most popular image data sets. So ImageNet, COCO, CFAR, and then the most popular video data sets are Kinetics and UCF. They're actually not the best data sets, I would say. I'd say there's a lot of work to be done on the data set side, and the number of papers that are working on this are 10x lower than the number of papers that are working on images. So people are still really focused on images. And the other reason that we've been wanting to develop this is, and this is kind of related to, I think, what Carson was talking about, that we're pretty passionate about developing usable and, in particular, trainable machine learning systems. So these are a couple of examples of software that we've developed over the years. This is Java here, and this is APT. Java is trying to do behavior classification, and APT is trying to do pose recognition. And you can develop a really big data set like Carson was talking about, that hopefully will work on every type of cell or every type of fly or whatever you're interested in. Or you might have a very specific type of problem, and we would like to be able to enable biologists or people in general to be able to train up their own machine learning classifiers for their problem of interest. So to really tailor things to the type of data that they work on. And one of the things that we've done, so I've been making these kind of usable interfaces for working with video since I was a postdoc. So C-Trax went back in 2007, and then Java was back in 2012, and then APT is something we're still working on. And every time we do it, we kind of start from the beginning with nothing, and we build almost exactly the same components over and over again. So like you can see there's some commonalities, I'll go back in this one, between these two interfaces. And partly that's because I kind of designed both of them, but I think there are components that are common between all of these things. So like you can see all of these have ways of viewing a video image and kind of scrolling around and looking at something over time. And so, possibly go forward. Okay. So our goal is to enable development of systems for annotating video and for training machine learning systems for video, both by computer scientists who maybe don't need to be using a GUI, but want to be working with video, and end users who will want to use a user interface to do these types of things. So what we've been thinking about is a library that consists of these three components. So there's a user interface that the non-expert user would be using for annotating, as well as for getting feedback about how the machine learning is working, maybe setting hyperparameters of the machine learning system, doing inference with their system. And then there are, so that would, we're thinking, be written in JavaScript and React. And then there's a back-end side of this, which consists of the data structures and the API and the storage for dealing with the actual types of data that this user interface is making available. And then there's another layer of communicating to the machine learning, to and from the machine learning. So both saving your data or transferring your data to the machine learning, the learning, the training, as well as to do inference. So just to, I if anyone's interested, I'd be very happy to kind of go through all the details of things that I've been brainstorming about this, but I thought I would just give a couple examples of the types of reusable components that I imagine there being in this library. So one example, as I was saying, you always kind of want to have some way of looking at video, which will consist of an image, which you can change which frame is being shown, some kind of annotation layer, like here I'm showing the clicked locations of these parts of the animal, and then maybe also layers showing feedback from the classifier, which could be things like the predictions of where these key points are, or other types of information that the classifier can provide us. Maybe things like competence in these predictions, or heat maps, or things like that. And we want to be able to control which frame is shown, so like things like sliders that are hooked up to this. Another type of component that we see in all of our user interfaces are these timeline views of the data. So you can think of this image here as kind of an XY slice of the data. We might also want to have T by some other variable slices of our data. So some variable that you might be interested in, things that we've plotted in the past are things like the velocity of the fly or the confidence of the classifier. You might also have these types of timelines, which they don't have a Y value. They're just kind of showing the manual labels that the biologist has provided, or which frames have labels on them. So that's a couple examples from the user interface. What we've been thinking about with the user interface, we've been talking with a few other groups who've been developing UIs, and we'd really like to have collaboration and connection to a lot of the other open source initiatives out there. And so we've been talking with someone who works on community science projects like Merlin, which is the bird identification software you might have on your phone, and then the Deep Cell kiosk from David Van Valen's group. And then the second layer is the data component. And there's a bunch of different types of data that, sorry, it's running in the background, that we would like to be able to analyze, or sorry, to support. And so one of the things that's just really annoying that everyone kind of has to deal with when they work with video is just being able to read lots of different data, video formats, and lots of different video codecs. I think on one of Carson's slides, she had like a list of the types of data that types of video, or types of 3D data that their Sweet2P supports. And like, it would be nice if we could just have, good support for a bunch of different types of video. We want to, one of the things that's pretty common, you don't want to have your video files stored within the project that you're saving. You actually want to kind of just have links to it. And people are always moving around their projects, for instance, to different file systems. So you want to be able to have support for changing properties of the file system. We also want to have support for being able to read these videos quite quickly, which might mean predicting which frames are going to be read in the future and buffering those. Another type of data component that we imagine having are annotations. And we could imagine this being kind of a inherited hierarchical definition, right? So there's kind of a general form that all types of annotations might take, which is some parameter vector and some information about what subregion of the video, both spatial and temporal, this corresponds to, some attributes that may be important to keep track of, and then some metadata. So some examples that we have would be for key points. This parameter vector would be just a list of the XY coordinates. The subregion of video would be the frame number that we are annotating. For behavior classification, we would just have a value of whether the behavior is happening or not happening as our parameter. Our subregion of video would be an interval of frames, and then the attributes that might be important to keep track of would be the name of the behavior that's happening. And so we've been thinking about how much we want to kind of tie ourselves to Napari with this project, and we talked with Eric Perlman, who's been working on Napari to some extent. And what we're thinking is that the data component would be something that we would work with people at Napari, working on Napari or to kind of make sure, to kind of learn from what they've done and possibly make things as compatible as we can. And I hear that Nathan Clack is now the person to talk to at CZI about these types of things. So we plan to contact him. And then some examples of the types of things we're thinking about with the communication to the machine learning. So there's two different types of things you want to do with machine learning, both training and inference. We would like to be able to support both cloud computing and local computation. Things that we'll have to think about is how we want to, things that would be in the library would be saving the training data to file in some reasonable format, as well as a data loader for PyTorch, for instance. We'd probably want to think about connections to various models used like OpenMM Lab. And again, we want to think about communication and connection with different projects that are going on. So just some initial things that we would want to be able to do. We would like to have support for the common components that we've been developing for APT, for Java, and for CTRACS. We'd like to make new components for the pose tracking. So a couple of the things that Sam and I have been talking about is better support for multi-camera tracking and for annotating 3D models with this. Something that MyInc, I think, has been pretty excited about is individual animal identity recognition. So being able to maybe use that as a test bed for this kind of a library. And that is what I have. And these are the people I have talked to or worked with on this project.